today's lecture. So in our last lecture, we had started the introduction part of fluid mechanics. Okay, we had seen what is the syllabus for fluid mechanics. Then we had seen the course outcome. Then we had seen the definition of fluid. Okay, so what is fluid? Fluid is the substance which undergo continuous deformation under the action of infinitely small shear stress. Okay, that means if you apply a shear stress on solid, so solid will have definite deformation, and if you remove the shear stress, it will regain its original shape and size. But fluid is a substance which will have continuous deformation or infinite deformation under the action of shear stress. Okay, then we had seen the difference between liquid, solid, and gases. We had seen fluid. Fluid is nothing but it also behaves as a continuum. Okay. Then we had seen difference between ideal fluid and real fluid. So ideal fluid is a fluid which has no viscosity, surface tension, and can be incompressible in nature. Okay. No fluid existing in nature is ideal fluid, so it is an imaginary fluid. Okay. But for practical purpose, water in case of liquid and air in case of gases are treated as ideal fluid. Okay, and all the fluid existing in nature which have other properties, they are real fluids. Okay, then we had seen fluid mechanics is nothing but it is a study of fluid at rest or in motion with or without considering the forces. Then the study of fluid at rest is fluid statics. In motion, it is fluid kinematics without considering the forces, and the study of fluid in motion considering the forces. They are it is called as fluid dynamics. Okay, and we have seen the variety of application that the fluid mechanics finds. Okay, now today we are going to start or we are going to continue our lecture. So our today's topic or next property which we are going to see, that is units. Okay, so what is unit? In general, unit is nothing but it is a standard in terms of which the physical quantities are measured. Okay, for example, how you are going to measure the length? You are going to measure the length in millimeter, centimeter, meter. Okay, so you had set the standards. Okay, and you has also defined the relation between them. For example, 10 mm equals to 1 centimeter, then 100 centimeter equals to 1 meter, 1000 meter equals to 1 kilometer, and so on. Okay, these are nothing but the standards which are set by us. So any standard in terms of which any physical quantity such as distance, velocity, acceleration, it can be measured. So these standards which are set, they are called as units. Okay, now first of all we will see these physical quantities, how these physical quantities are classified. Okay, so the physical quantities are classified as primary or fundamental quantities and secondary or derived quantities. So what is primary or fundamental quantities? So the definition is these are the quantities in which does not depend on any other quantity for its existence. Okay, for example, uh, mass. Okay, can you tell me what is the length of the mass? Can you tell me the time of the mass? Okay, so mass will not depend on temperature, mass will not depend on time, mass will not depend on distance for its existence. Okay, so it is a quantity which can be defined by its own. Okay, mass को define करने के लिए आपको उसका temperature नहीं बताना है. जैसे 25 डिग्री पे 1 kg मास है तो 50 डिग्री पे 2 kg मास हो रहा है भाई. ओके, ऐसा नहीं होता. ओके, 150 डिग्री पे 1 kg मास है तो 25 डिग्री पे भी 1 kg मास रहेगा. Okay, so it is not depending on temperature, it is not depending on the dimension, it is not depending on the length. Okay, so it is a independent quantity or primary quantity. Similarly, 1 minute. Okay, similarly, the other physical quantities are length, time, and temperature. Okay, so these are the quantities which does not depend on other quantities for their existence. So such type of quantities are called as fundamental or primary quantities. Okay, so there are only four primary or fundamental quantities. They are mass, length, time, and temperature. Okay, so for defining the mass, you will not require its length, you will not require its time, you will not require its temperature. Similarly, for defining the area, okay, आपको area of square पूछा है या area of circle पूछा है, so you will not require the mass of the circle, you will not require the time of the circle, you will not require the temperature. Okay, so this mass, length, time, and temperature, these are only the four fundamental or primary quantities, okay, existing in nature. Okay, then the other type is secondary or derived quantities. So this secondary or derived quantities, these are the physical quantities. It depends on this primary quantities for its existence. For example, velocity. Okay, now what is velocity? This velocity is distance upon time. Okay, now suppose the distance is changed. Okay, suppose आपके पहला velocity है, that is distance covered is 100 kilometer. Okay, and time is 1 hour. Time is 1 hour, you are covering 100 kilometer in 1 hour, so velocity will be 100 kilometer per hour. Now suppose I am taking the time constant 1 hour, but now the distance is changed to 50 kilometer. Okay, so whether its velocity is changed, yes, because its new velocity will be now 50 kilometer per hour. Okay, so it is depending on distance. Okay, it is depending on length to be covered. Similarly, consider the third case. In third case, I am taking the distance same 100 kilometer. Okay, but here now time required is 2 hour. Okay, 2 hour. So in this case, whether the velocity is changed, answer is yes. Okay, so this velocity is also depending on time for its existence. Okay, so all the quantities which depends on more than one primary quantities for its existence, so that type of quantity is called as secondary quantities. So example of secondary quantities is velocity, acceleration, okay, then mass density, okay, and so on. So all the properties which we are going to learn in this unit number 1, all these are secondary quantities. Okay, then what is dimension? Now this dimension is nothing but the mathematical representation of secondary quantities in terms of primary quantities. Okay, so the mathematical representation of, or if you are going to specify the secondary quantities in terms of one mathematical equation, so that mathematical equation is covered by square brackets. Okay, there will be square brackets. Okay, then inside the square brackets there will be four primary quantities, that is m, which represent mass, l, which represent length, time, capital T will represent time, and theta, okay, it will represent temperature. Okay, then what is the magnitude of mass for that quantity? So that is denoted by to the power a. Okay, m to the power a. Similarly, the magnitude of length will be determined by index b, for time the index c, and for temperature the index d. Okay, so the mathematical representation will be m to the power a, l to the power b, t to the power c, and theta to the power d. Okay, this representation, it can be used for all fluids. Okay, but this theta we are going to specify it for gases. Okay, they are specified for gases, air, and other uh, gases. Okay, why? Because gases have the property that for a small change in temperature, their physical quantities changes considerably. Okay, that is volume of the gas will change for change in 1 degree temperature. Even mass of the gas will change. Okay, for a 1 degree rise in temperature. Okay, volume may change, and density may change due to change in temperature. Okay, Okay, so for gases, okay, gases के लिए हम represent करते हैं m to the power a, l to the power b, t to the power c and theta to the power d. But for liquids, okay, for liquids there is no considerable change in temperature, change in property due to change in temperature. Okay, and in fluid mechanics we had discussed yesterday that we are going to talk about the liquids. Okay, properties of liquids. So for liquids, the notation used is m to the power a, l to the power b, t to the power c. Okay, तो हम हर प्रॉपर्टी के डायमेंशंस जो है ये डिटरमाइन करेंगे. Okay, in the form square bracket m to the power a, l to the power b, t to the power c. Okay, then there is a separate unit, our unit number 6. It will be dealing with units and dimensions. Okay, so डिटेल में हम units and dimension unit number 6 में देखेंगे. Okay, but right now you are just supposed to remember how to represent the dimension. Dimensions are represented in square bracket uh, by m to the power a, l to the power b and t to the power c, where a, b, c are nothing but these are the index which will going to represent the magnitude of primary quantities in terms of secondary quantities. Okay, so after all this we will start with our first property of fluid, that is mass of the fluid. Okay, so first of all, what is mass? Mass is nothing but it is a quantitative measure of matter. Okay, whatever the matter which is present in a particular body, that can be measured in terms of mass. So mass is simply denoted by small m. Okay, what is the unit of mass? The unit of mass is gram in CGS system and kilogram or kg in SI system. Then what will be the dimension of mass? So dimension of mass will be square bracket m to the power 1 L0 T0. Okay, remember the mass is a primary quantity, so there is no magnitude of length and no magnitude of time. Okay, so it is m1 L0 T0. Okay, then the next property that we are going to see, that is mass density. So mass density is nothing but mass per unit volume of the fluid. Okay, so mass per unit volume of the fluid. Okay, that is this mass divided by volume of the fluid. So this is nothing but mass density, and this mass density is denoted by Greek symbol rho. Okay, so mass density is nothing but mass of the fluid divided by volume of the fluid. Okay, now what is the physical significance of mass density? Okay, so mass density will going to represent in a particular volume. Okay, in a particular volume, suppose it is a cubical volume of 1 meter length, 1 meter height and 1 meter width. Okay, so its volume will be 1 meter cube. Okay, so how much mass is present in 1 meter cube volume? Okay, so that will going to represent mass density of that particular fluid. Okay, so if more mass is present, you can see here, if more mass is present, so the value of density will be high. Okay, and if less mass is present in a particular volume, then its mass density will be low. Okay, so the unit of mass density will be mass upon volume. So SI unit is kg per meter cube and CGS unit is gram per centimeter cube. Okay, then what will be the, sorry, there is one correction. Okay, what will be its dimension? Its dimension will be, in numerator it is mass, so m1. Okay, then in denominator it is divided by L cube, sorry, volume. So volume is nothing but it is area or length into breadth into height. Okay, so it will represent L dimension. This B is again L and LH is again represent the length. Okay, so it is L cube and it is in denominator. So when it will go in numerator, it will become minus 3. Okay, so it is m1 L minus 3. Okay, m1 L minus 3 T0. Okay, So it is nothing but it is a dimension for mass density. Okay. So you can represent this mass density rho in square bracket. Okay. So the dimension of mass density is m1 L minus 3 T0. Remember, these dimensions are very important because it dimension के ऊपर आपका पूरा एक unit है. Unit number 6 will be totally on this dimension. Okay, so you should know how to calculate the dimension or how to determine the dimension for any physical property. Also in Viva, okay, mostly the dimensions are asked. Determine the dimension of viscosity, determine the dimension of mass density, and so on. Okay, so remember this method how to determine the dimension for any property. Okay, then also remember the values for mass density. Okay, so the mass density for water is 1000 kg per meter cube. Always remember this value. Okay, for mercury, the mass density is 13,600 kg per meter cube. So what it represents? This value is 1000 and this value is 13,600. So which value is bigger value? Value of mercury. Okay. So you can say water is lighter than mercury or mercury is heavier than water. Okay. That means if you mix, if you take a container and if you mix water and mercury, okay, so you will observe mercury will settle at the bottom and water will float upward. Okay, why this is happening? Because the mass density of mercury is higher than water. Okay, similarly, the mass density of petrol is 730 kg per meter cube. Okay, या आप पेट्रोल पंप पे भी चेक कर सकते हो. If you visit the petrol pump, there are three values which are given. First is rate, second is volume. आपने कितना वॉल्यूम फिल किया है, 1 लीटर 2 लीटर, एंड बाजू में एक थर्ड इंडिकेटर होता है, उसमें उसका डेंसिटी बताया जाता है. ओके, so density of petrol is nearer to 700 or 730. That means if you mix petrol and water, so you will observe petrol will float above and water will settle at the bottom. Why? Because density of water is bigger than density of petrol. Okay, so remember this reason, whenever two fluids are mixed, so the fluid having lower density, okay, it will be a lighter fluid and it will float, and the fluid having more value of density, it will be heavier fluid and it will settle at the bottom. Okay, then the next property which we are going to see, that is specific weight. Okay, or sometimes in some books it is also called as weight density. Okay, so this specific weight or weight density, it is nothing but it is weight per unit volume of fluid. Okay, so it is simply defined as the weight of the fluid per unit volume of the fluid, or weight of the body per unit volume of the body. Okay, so this specific weight is nothing but weight upon volume. It is denoted by Greek symbol gamma. Okay, so gamma is nothing but gamma is equal to weight of the body W divided by volume of the body V. Okay, so its unit will be, what is the unit of weight? Weight is nothing but force applied by the body on the earth's surface, or equal and opposite force the earth apply on any body. So it is measured in terms of Newton. Okay, so its unit is Newton per meter cube in SI system and dyne per centimeter cube in CGS system. Okay, after that dimension. Okay, now remember how to calculate this dimension. Remember always how to calculate the dimension. So the dimension of specific weight gamma, okay, it is nothing but dimension of weight divided by dimension of volume. Okay, now dimension of weight, weight is nothing but force. Remember by Newton's second law, force is nothing but it is a product of mass into acceleration. So unit dimension of force will be dimension of mass. Mass is nothing but m1, and acceleration, what is the unit of acceleration? meter per second square. So its dimension will be L1 t minus 2. Okay. रिमेंबर दिस डायमेंशन बिकॉज आपको पूरे 6 यूनिट में कोई भी डायमेंशन डिराइव करने के लिए आपको फोर्स का डायमेंशन पता होना चाहिए. सो इट इज m1 l1 t minus 2. Okay, and this force is nothing but weight is nothing but force, so you can replace here. So it will be m1 l1 t minus 2. Okay, m1 l1 t minus 2 divided by volume. Volume is nothing but m0 l3 t minus 2, sorry, t0, m0 l3 t0. Okay, now for calculating this dimension of specific weight, we will take this mass above, so it will be m1. Okay, denominator को ऊपर ले जाते टाइम हम माइनस करेंगे, so it will be m to the power 1 minus 0, so it will be m1. Okay, then second is L1 and L minus 3. So L minus 3, L3 will go upward, so it become L minus 3. So it will be L1 L to the power 1 minus 3. So it will be L minus 2. Okay, ये 3 को आप upward ले जाओगे, so it will become minus 3. So it will be 1 minus 3, that is minus 2. Okay, then t to the power minus 2 minus 0. Okay, so it will be t minus 2. So the dimension of specific weight is m to the power 1, l to the power minus 2, t to the power minus 2. Okay, remember this process. Okay, how we had calculated the dimension for specific weight. Okay, then next is, what is the relationship between these two property, mass density and specific weight? So we know specific weight is nothing but weight per unit volume, and we know weight is nothing but mass into, or weight is nothing but force. Okay, weight is nothing but force, and we know force equals to mass into acceleration. Now whenever the body is dropped, okay, from a particular height, the acceleration with which the body comes towards the earth's surface is acceleration due to gravity. Okay, so this weight is nothing but mass into acceleration due to gravity. Okay, so it is mass into g divided by volume, and we know this mass upon volume is nothing but mass density. Okay, so the relationship between gamma and rho, specific weight and mass density, is gamma equals to rho g, or specific weight is nothing but mass density into acceleration due to gravity. Okay, therefore we can calculate the value of water. So for water, the specific weight of water is nothing but density of water, which is 1000 into g. So it is 1000 into 9.81. Okay, so it comes out to be 9810 Newton per meter cube, or in terms of kilonewton, it is 9.81 kilonewton per meter. Okay, then the next property which we are going to see, that is specific volume. Okay, so as the name suggests, specific volume. Okay, so this specific volume is nothing but, it is the ratio of volume per unit mass of the fluid. Okay, that means in a particular, okay, in a particular mass, okay, in a particular mass, suppose 1 kg mass. Okay, what is the volume it will going to occupy? Okay, that means more the value of specific volume, more volume will be occupied for containing 1 kg of mass. The value of specific volume, less volume will be required for occupying the specific 1 kg of mass. Okay, after that, our next property is specific gravity. So specific gravity, it is denoted by small s. So it is nothing but, it is the ratio of specific weight of the given fluid, okay, to the specific weight of standard fluid. Okay, remember for fluid mechanics, the standard fluid is taken as water. Okay, so simply it is a ratio of specific weight of the given fluid to the specific weight of water. Okay, so S is nothing but gamma of fluid divided by gamma of water. Okay, as it is a ratio of two similar quantities. Okay, what is the unit of specific weight of fluid? It is Newton per meter cube divided by unit of specific weight of water is again Newton per meter cube. So this Newton per meter cube cancels, so it has no unit, and it has no unit, it has no dimension. So it is unitless and dimensionless. Okay. After that, what will be specific gravity for water? It will be the ratio of specific weight of given fluid, which is water, divided by uh, specific weight of standard fluid, which is water. Okay. So gamma W will cancel. So remember the specific gravity of water is 1. Okay. Now what is the significance of specific gravity? Now suppose we will take the case of mercury. Okay. Specific gravity of mercury. Now we know it will be the ratio of specific weight of mercury divided by specific weight of water. Okay. So it is 13600 divided by 1000. Okay. So 0 will cancel. So it is 13.6. Okay. So the specific gravity of mercury, it will be greater than specific gravity of water. Okay. So if you mix mercury and water, you will observe water will float at the top and mercury will settle at the bottom. Okay. That means if there are two fluid, so the fluid having more value of specific gravity, okay, it will settle at the bottom, and the fluid having lesser value of specific gravity, it will float. Okay. Similarly हमने केस देखा था पेट्रोल और वाटर का. Okay. So specific gravity of petrol. Okay, it is nothing but it is a uh, specific weight of petrol divided by specific weight of water. Okay, so it is rho petrol into G divided by rho water into G. So G will cancel. Then we know mass density of petrol is 700 and mass density of water is 1000. Okay, this 20 will cancel. So it is 0.7 specific gravity of petrol. It is 0.7. Okay. So specific gravity of petrol, it is less than specific gravity of water. Okay. So again, if you are mixing petrol and water, you will observe petrol will float at the top and water will settle at the bottom. Okay. So remember these differences. Okay. So this is the physical significance of specific gravity. So if you know the value of specific gravity for any fluid, okay, if that value is more than 1, so you can say if you mix that fluid, so that fluid will settle and water will float. Okay. And if the value of the given fluid specific gravity is less than 1, so in that case you can directly say the water will settle at the bottom and that fluid will float. Okay. So remember the significance or importance of this property, that is specific gravity. Okay. After that, we will solve one numerical on the above learned properties. Okay. So our numerical is calculate the specific weight, mass density, and specific gravity of 1 liter of liquid which weighs 7 Newton. Okay. So basically we are supposed to calculate. Okay, voice break. आता येते का पवन voice? Hello. Okay. So our problem is calculate the specific weight, mass density, and specific gravity of 1 liter of liquid which weighs 7 Newton. Okay. So remember these are the very simple problems and they can be asked for 4 marks in same examination. Okay. So what is given in the given problem? Volume of the liquid is given as 1 liter. Okay. And weight is given as 7 Newton. Remember the relation. Sorry. Remember the relation 1 liter, okay, or 1 meter cube is nothing but 1000 liters. Okay, 1 meter cube of any liquid is nothing but 1000 liters of that liquid. Okay, similarly 1 liter is nothing but 1 by 1000 or 10 power minus 3 meter cube of that liquid. Okay, remember this conversion for solving the problem. Okay, so volume is 10 to power minus 3 and weight is 7 Newton. Okay, so first of all we will calculate specific weight. Okay, so we know the specific weight is nothing but gamma is equal to weight of the fluid W upon volume, that is 1 upon 1000 meter cube. Okay, the specific weight is 7000 Newton per meter cube. Okay, यहाँ पे gamma चाहिए था actually. Make one correction here. Gamma is given. Okay, so gamma equals to 7000 Newton per meter cube. Okay, after that next is mass density. Okay, so we know the relation gamma equals to rho into g. Okay, so the mass density rho is nothing but gamma upon g. Okay, in some books gamma को w use किया है. Okay, so some कुछ books में gamma use किया है और कुछ book में small w use किया है for specific way. So it is small w upon g or gamma upon g. So it is nothing but 7000 divided by 9.81. Okay, so it is 713.5 kg per meter cube. Okay, then last thing is specific gravity. So specific gravity is nothing but it is a ratio of density of any given fluid to the density of water. Okay, so it is 713.5 divided by 1000. Okay, so it is 0.7135. Okay, so this fluid is heavier than water or lighter than water. It is lighter than water. Okay, जो भी given fluid है इसको आपने water के साथ mix किया, so water will settle at the bottom and this fluid will float. Okay, again quickly we will solve one more numerical and we will stop today's lecture. Okay, so our next numerical is calculate the density, specific weight and weight of 1 liter of petrol of specific gravity 0.7. ओके, तो ये प्रॉब्लम में आपको क्या दिया है? ये प्रॉब्लम में आपको 1 लीटर ऑफ पेट्रोल बोला है. सो वॉल्यूम इज 1 लीटर और 1 अपॉन 1000 मीटर क्यूब. ओके, और 10 पावर माइनस 3 मीटर क्यूब. ओके, देन specific gravity is given to you as 0.7. Okay, so we know specific gravity. Okay, first of all we will calculate the mass density. So we know specific gravity is nothing but ratio of gamma of given fluid. Okay, specific weight of given fluid which is petrol divided by specific weight of water. Okay, and we know specific weight is nothing but density of petrol into g divided by density of water into g. So g will cancel. Okay, you can multiply this specific mass density of water with specific gravity. So density of petrol is nothing but S into specific weight of mass density of petrol. So it is S into 700 kg per meter cube or 0.7 into 1000. Okay, so it is 700 kg per meter cube. Okay, after that specific weight, so we know specific weight is nothing but W or gamma equals to rho into G. So it is 700 into 9.81 Newton per meter cube. So it is 6867 Newton per meter cube. Okay, after that next is weight of 1 liter of petrol. Okay, so we know if you know the specific weight gamma, so gamma is nothing but W into W divided by volume. Okay, so if you multiply the volume, so W is nothing but specific weight into volume. Okay, so weight specific weight is weight upon volume. So weight is nothing but specific weight into volume. Okay, so it is 6867 into 10 power minus 3. So it is 6.8 867 Newton. Okay, so today we will stop here, and from next lecture we will see the next property, that is viscosity. Okay, wait 1 minute, I'm taking the attendance.